take a look at the next problem, the very next problem. And at first glance, Marissa, the next problem looks very much like the ones we've been doing, right? All right, take a close look at it though. Do you notice anything about it? It's a little bit different. Okay, f of x is the same as y, so I'm not worried about that. Look at the problem itself. Do you notice anything about it?
Does it factor?
Well, here, yeah, the deal is, folks, we've been factoring by grouping, right?
Mm-hmm.
Now,
Groups that you take out on
people will say, well, Mrs. Ford, you can factor. Philip, are you okay?
Yeah.
Okay. So we can take an x squared out and be left with x plus 2. That's fine. There's not much we could do here, but maybe take out a negative 1, and we'd be left with 5x plus 6.
It's not the same.
It's not the same. And the only way this works is if the parentheses turn out to be the same. They're not going to turn out to be the same. So that strategy is going out the window. You're not going to believe what I'm about to tell you. When you can't factor by grouping, remember, you are looking for the parentheses. You need some factors. You're looking for parentheses. And why do you need parentheses? Because the parentheses tell you where to put the dots, right? Like 1, 0. The factors give you the dots. The dots are the numbers that give you 0 when you plug them in. When you plug a 1 in, you get 0. So what we're going to do right now is we're going to guess. We're going to guess numbers, and we're going to plug them in and try to get it to equal 0. That's what we want. We want to know what numbers will I plug in that will give me 0. Now, does anybody have any concerns about that? It could take a while, because when I say to you, let's guess some numbers, how many numbers are there? Infinity. Yeah, there's a lot. So depending on how good guessers we are, we can be doing this for a really long time. Luckily, some really smart people a long time ago came up with something called the possible rational root theorem. The possible rational roots. I call them PRRs. And that's why on the paper you'll notice I have a little PRR over there to the side. Because before you start guessing, I want you to narrow down your options. Right now, you're sitting there and you have the whole wide world of numbers out in front of you, okay? I want you to have a little bucket of numbers, so we're going to narrow it down. You're still going to have to guess, but you're only going to guess from this little bucket. Now, what does the possible rational rule say? It says that your possible rational roots are factors of the constant over factors of the leading coefficient. Now, I don't think any of you were born knowing the possible rational root rule, so you might want to write that down. This is called the possible rational root theorem, and it says that any possible rational answer, in other words, any number you're going to guess, is going to be constructed from the factors of the constant over the factors of the leading coefficient. Mrs. Ford, What do you mean by constant? This number at the end with no variable is called the constant. The plain number is called the constant. The number in front of the x cubed or the x to the fourth or whatever the biggest power is, the number in front of the biggest power is called the leading coefficient. You've heard that before, right? Now, my constant is 6. Actually, it's -6. The factors of -6 are plus or minus 1, 2, 3, and 6. In other words, these are the numbers that will divide into -6. Okay? Alright, so the numbers that will divide into -6 are 1, 2, 3, and 6. The leading coefficient, if we're lucky, is just 1. So that's the best number to have. Because that means you're not going to have any fractions. You have 1 over 1, 2 over 1, 3 over 1, 6 over 1. So a minute ago, you had infinitely many numbers to guess from. Now you have 8. Why are there 8? Plus or minus those 4. So here's my bucket of numbers. Only has 8 numbers in it, so the most I'm going to have to guess is 8. I'm going to reach in and grab one. I'm going to plug it in, and what do I hope happens?
0.
I get 0.
It's about it.
Okay? So here we go. Let's try one. What's the first number you want to try?
-3.
-3. All right, let's try -3. Now, you may need a calculator because you have to take -3 cubed plus 2 times -3 squared minus 5 times -3 minus 6. All right, so you may need a calculator to do that. I'm going to try to do it without a calculator, but I'm old, I'm the teacher. Let's see. -27 plus 18 plus 5. Oh my gosh, you guys are amazing. There we go. That one equals 0. So we got it on the first guess.
We got 7 more chapters.
Okay, now wait. Stop, because we're not going to guess anymore. Here's what, in a minute I'll tell you what we're going to do. But what if -3 hadn't worked? What would I do?
Just another.
Guess again. And I would pick another one of my numbers, and I'm going to keep guessing until 1 equals 0. Now, the minute you get a 0, I want you to write that factor down. Remember, we had to factor this. So the first factor will be x plus 3. Why is it x plus 3? Because the 0 is at -3. That's the point that you would put on the graph. Does that make sense to you then, that the factor is x plus 3? Okay. Now we're going to do synthetic division. You have all done this before. I checked with your teacher. We've done synthetic division before. So out here in the box or the circle or whatever shape you put out here, you're, no, these are our PRRs. Our factor is x plus 3. Remember, we're trying to build this into factors so we can graph it.
Big.
It's a big problem. There's a lot going on.
How'd you get the x plus 3 again?
This number is a 0.
Oh,
That
okay.
means on my graph, I'm going to have a dot at -3. If the dot's at -3, then the factor was x plus 3. Okay, so this -3, whatever number gave you 0, put in the box. These are the coefficients from the problem. 1, 2, negative 5, negative 6. Now remember how this works? Drop this 1 straight down. And I find it's helpful to use an arrow to remind myself that number's coming straight down. Then you remember, you take this times this and write it here. So this times this and write it here. Now we add. Then we take this times this and write it here. And we add. Then we take this times this and write it here. Oh my goodness. That is your remainder. When you do synthetic division, that is your remainder. And why am I excited? Because if the remainder is 0, I have indeed found a factor, right? That better come out to be 0. If it doesn't, we're off base. So let's go through that process one more time. Where do these numbers come from right here? That's the problem. This comes straight down always, whatever it is. This times this, write it here, add. This times this, write it here, add. This times this, write it here, add, and it better be 0.
If it's not 0,
that means you don't have a factor. You've either screwed up or it's not a factor. Now, what's this?
The other ones?
John? Nothing?
squared minus 1x.
Exactly. We call that our depressed polynomial. Some of you might be depressed at this moment. That's our depressed polynomial. Depressed because it's been made smaller. What do you think we might do with that?
Factor it.
Yes! That we can go ahead and factor. So what does that become? X minus 2, x plus 1?
Yes.
Okay, we aren't done. Oh my gosh, look at all the work we did. We're not done because we still have to graph it. We still have to graph it. So here are our factors. We have our factors. Graphing it will be easy now because in order to graph it, all we have to do is put our dots on there. Where will our dots be? Negative 3, 2, and negative 1. Are any of them squared? No. It's a cube. Odd. Starts down. No bouncing. Nice and smooth. There we go. Wow. That's a big time problem. Let's do one more. One more. We got time. We'll get one more done, or at least started.
Where did the 3 come from this for?
The factor of 3, that's the one we guessed, remember? That's the one we guessed.
So when you do, you get
We divided it out. Yep. You always do the opposite. So the number you divide is the number you would plot on the number line. So when you put negative 3 on the number line, that's the number you divide by. Whatever number you graph is what you divide. Okay, here we go.
If the constant is positive, is it still plus or minus?
Yep, always plus or minus. Because BT 10 is divisible by negative 5.
Yeah.
Right, so it's always plus or minus. Okay, here we go. F of x equals x cubed minus 6x squared plus 11x minus 6. Now, the first thing that should pop in, hey. Okay, most of you can't afford to be screwing around. This is hard stuff. The first thing we think about is, I wonder if it groups. Because if it groups, then I don't have to do all that guessing and synthetic division and all of that. But when I look at these numbers and I see a 1 and a 6 and an 11 and a 6, I'm not hopeful that it groups. Would you agree with that? It just doesn't look good to be grouping.
I would have to agree.
So, I know, okay, if it doesn't group, then I'm going to have to guess. And my PRRs, my possible rational roots, are factors of that number. So that would be 6, 3, 2, and 1 over factors of this number, which is just 1. It's always factors of last over first. Okay, last over first. So now your pile is pretty much the same as it was in our last example, and you're just going to guess a number. What? -2. So he wants to guess -2. So that'll be -2 cubed minus 6 times -2 squared plus 11 times -2 minus 6. This one, we're not lucky on this one. We're going to get -8 minus 24 minus 22 minus 6, which is not 0. I don't know what it is, but there's no way it's 0. Would you agree with me? Let's try +2. That might work. So 2 cubed minus 6 times 2 squared plus 11 times 2 minus 6. I'm just plugging in whatever my guess is. We guessed -2, didn't work. Guessing +2 now, so I'm putting it in. I get 8 minus 24 plus 22 minus 6.
What about math? That equals 0.
That does equal 0. That adds up to 0. So one of my answers, one of the dots on my picture is going to be at 2. Which means my factor is what? If the dot's going to be at 2, where's my factor? X minus 2? All right, who remembers from our last example? What do I do now? I've got a number that equals 0. What do? Synthetic division.
Here you go.
So in the box goes the 2. Across the top goes 1, -6, 11, -6.
Yeah, the hot minute.
Those are the numbers from the problem. This comes straight down, always, 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 whatever it is. 2 times 1 is 2. Add. 2 times -4 is -8. Add. 2 times 3 is 6. Add and get 0, which is your remainder. What's left here? X squared minus 4x plus 3. What do you notice about x squared minus 4x plus 3? It factors, as Marissa says, into x minus 3, x minus 1. So I already knew I had a dot at 2. I also have a dot at 3. And I have a dot at 1. They're all close together this time. Are any of them squared?
No.
It's a cube. There we go.
Oh, we get out right
There
now.
it is. That is pretty darned amazing, isn't it? All right. We'll pick up here next time I see you, which is Tuesday.
Let's
All right,
go.
you two, can you get that for me, please? If you need to stay in